In the previous video, we discussed about the paper chromatography. If you want to watch that video first, the link is in the description. Now here we are going to discuss about the TLC, that's thin layer chromatography. We know it's a technique for separating or identifying the components of a mixture using adsorption or partitioning principle. And this chromatography is performed on TLC plate, made up of a non-reactive solid material coated with a thin layer of adsorbent material. And moreover, we see this adsorbent material acts as a stationary phase in TLC, which can be silica gel or alumina. Then we have the mobile phase, which is solvent like methanol or ethyl acetate. So we see the stationary phase is silica gel in TLC or alumina, which is a thin uniform layer coated on a plate. And then we have the mobile phase, a solvent, which travels up the stationary phase carrying samples with it. Now moving towards the TLC plate, a glass slide on which we have a thin uniform layer of silica gel. Here in this diagram we have glass slide, and on which we put on the thin layer of silica gel shown in the diagram. This silica gel is polar in nature. Then we move on to mobile phase, which is methanol or ethyl acetate. This phase is non-polar in nature. If we take up the TLC plate and run the chromatography, we get results like this. Some components of the mixture have moved far away from the initial point, and some components are in the middle. This upper one shown in the diagram is the less polar component, whereas the lower one is highly polar in nature. Now let's see how chromatography works. We take a jar with solvent mobile phase in it. Then we take a TLC plate and put a sample mixture on it and let it dry. After some time, this TLC plate is transferred into a jar in such a way that the mixture spot should be above the solvent line shown in the diagram. Then we close the jar and let the solvent go up with capillary action. And finally, we get the separation of components as shown in the diagram. Now to calculate the retardation factor values or RF values, we know RF is equal to the distance traveled by a compound or component divided by the distance traveled by the solvent front. Now we move on to different types of visualization methods in TLC. First one is UV visualization, used for organic compounds. In this technique, at the end we do not see any separation. But once the TLC plate is exposed to UV, we see the visualization of spots. Second one is ninhydrin treatment. This is used to detect amino acids. Here in this diagram we have final result after running amino acid mixture in thin layer chromatography. At the end we do not see any kind of spots that show separation. But once we spray the TLC plate with ninhydrin, we get the visualization of amino acids with purple or violet spots shown in the diagram. Then we move on towards the iodine vapor that detects organic compounds also. Mostly it is used to detect the hydrocarbons. Here in this technique, the TLC plate within the TLC chamber is exposed to iodine vapors that results in yellow spots. Fourth one is silver nitrate spray, where dark spots form upon exposure to light. Silver nitrate is a well-known method for separating non-polar compounds with similar polarities. Then we have sulfuric acid treatment followed by heat, where we get the permanent charred spots. It's used for general detection method for hydrocarbons. Furthermore, we have different methods like bromocresol green, the specific detection method for carboxylic acids. Then we have 2,4-dinitrophenylhydrazine, the general detection method for aldehydes and ketones. Then we have Dragendorf's reagent, a general detection method for alkaloids, quaternary bases, nitrogen containing compounds and lipids. And the last one is fluorosamine, a specific detection method for primary amines. So this is what TLC, that's thin layer chromatography, is and its techniques. I hope you like the video. If you like it, give it a thumbs up. Do consider supporting my work on Patreon or YouTube and make sure to subscribe to the channel. Thanks.